GM. If I'm not happy. GM. Okay. So this morning we're talking about authentication and authorization. So what's authentication and what's authorization? Also going to be talking about secret and secrets management. So authentication involves verifying your identity to a computer system. So for example, now, authentication is all about the question of who are you. Do you get me? It's all about who are you. So there are different ways you can use to prove who you are to the computer system. One of the most common ways is using password authentication. So password authentication involves users verifying their identity by providing the correct combination of usernames and passwords. So you can prove to the computer system that you are someone. You meant to provide the right username and the password to the computer system, which will authenticate you. Do you get me? So this username at times can be emails, can be anything, but basically it's all username and password. So anything that involves password is password authentication. We all know what password is, right? Strings of words and numbers and special characters that you can, use to authenticate yourself. So yeah, that's what password is all about. We all know what password is already. So the next thing is cryptography authentication. So cryptography authentication requires the authenticating party to sign a message and send it to the authenticator. The message to be signed should contain a nonce, timestamp, or both to prevent replay attacks. So what's the meaning of this? I think this is a new concept to most of us here, cryptographic authentication. So now when you want to authenticate to a system, what you do is that, we have private key and public key, right? So your public key is made available to anyone can check your public key. They can check your public key, but your private key, it has to be private to you. So if everyone can see your public key and your private key is meant to be kept to you. Now, how do you now verify yourself to a system? If you try to use your public key, anyone can have access to your public key. Do you get what I'm trying to say? So anyone can authenticate on your behalf. Then if you try to use your private key, how are you sure that that system receiving that private key will not compromise your private key? Do you get me? So that system can also authenticate on your behalf somewhere else because you can use the same private key to authenticate to multiple systems. Do you get what I'm trying to say? So because you can't change your private key easily, unlike password. So let me check people online. Okay. So what we do is that we sign a message with our private key. We do what? We sign a message with our private key. Then we send it to the authenticator. So once the authenticator receives the signed message, it's going to check whether the message was actually signed by my private key. How do you do that? There are a lot of algorithms that you can use to do that. What you do is that you now you try to confirm the private key that was used to sign the message by retrieving the public key from it. Do you get what I'm trying to say? If I sign a message and I send it to you, although you don't know the private key that signed it, right? But there are algorithms that you can use to calculate the public key of that of the signer. Do you get what I'm trying to say? So once you get the public key of the signer, then you now correlate it. Oh, this Mr. Biola is the owner of this public key, right? That means it's coming from Mr. Abiola. Do you get me? Even without knowing the private key of that person, the person can still authenticate by signing a message. For example, if I want to send a letter to someone, I don't need to send my own stamp with the person. What I just need to do is just append the stamp. So when the person receives the letter, the person checks, oh, this is from Mr. Abia, because the person knows my public key already. Do you get what I'm trying to say? So don't worry, we're going to do the practical aspect, and it's going to become more glaring. The next thing again is that apart from just authenticating, there's a problem that we need to also solve. It is called replay attack. This replay attack, unlike password-based authentication, these replay attacks affect cryptographic authentication. Just imagine that I want to authenticate to Mr. Sam. So I sent a signed message, right? Mr. Sam received that signed message. So what prevents Mr. Sam from using that key like another time again, maybe to another system that I'm authenticated on? How do you prevent that? The only way to prevent that is by using what we call a nonce, which is just, it stands for nonsense, but we've shortened to nonce. So it's called a nonce. So what I would do is that if I authenticate the first time, I will add 1. Do you get? So Mr. Sam is going to keep a record of my current nonce. So if I try to authenticate the second time, what should be my nonce? 2, right? So if I send Abiola, I can append 2 to it, then sign and send to Mr. Sam. So if I want to send and authenticate again, I'll do what? Abiola 3, right? And sign, send it to Mr. Sam. Mr. Sam is going to know that, okay, if Abiola is sending another message now, it should be what? 4. It should be 5, and just like an increment. But also, you can use random nonce, which is maybe like 20, 50, 100 randomly. Do you get? But you can't repeat the same nonce. But because Mr. Sam is going to keep record of that nonce. The another thing again is you can also use timestamp that, okay, this signature will expire after 5 seconds. Then also you can combine it so that, okay, I want to sign a message to Mr. Sam. The nonce is 1, and this signature, whether Mr. Sam honors it or not, is going to expire in the next 5 seconds. Do you get it? So we're going to combine the two. So that's how to prevent replay attack. And also, when you have a very complex system, maybe like we have multiple authenticators on the system. So Mr. Sam, now, even though I sent maybe like nonce 1 to you, right? Abiola 1, Abiola 2, Abiola 3, it doesn't still prevent the attack like that. At times, you might also need to append the name of the person or the public key of the person that is going to honor that authentication request. Do you get me? So if I want to send a message to Mr. Sam, I can say Abiola 1, Sam. Do you get? Then I'll send it to you. Then when you check, okay, Abiola, coming from Abiola 1, nonce 1, then who is meant to honor the authentication request? Mr. Sam, right? So if I want to authenticate with AJ, I can be like Abiola -1, AJ, the same nonce, but 2 different systems. Do you get how it works now? Do you get it? So there's going to be a timestamp append. So once we do the practical aspects, you understand it better, because at times these things are abstract. Yeah. Then, okay, the next thing is authorization. Authorization is different from authentication, but they work hand in hand. One thing about authorization is that it involves granting or refusing access to particular functionalities within a system based on roles and permission. Based on roles and permission. Do you get me? So let's assume that I'm an admin on a system. You know, I have higher privileges, right, than someone that is just a user on the system. Do you get me? So now, authorization are the things that you can do, the functionalities that you can have access to after you have been authenticated. If I authenticate as an admin, I'll be able to gain the admin role, right? Then the admin role have a lot of permission attached to it. Maybe I can delete what other people can, I can restrict what other people can see, I can delete data, I can do this, I can even add more users. Do you get me? So that's what authorization is all about. Authentication is proving who you are. Then authorization is what you can do, what you can access. Yeah. So there's this kind of authorization and authentication standard. It's called JWT, JSON web-based web token, JWT. So now this JWT is very lightweight. It's a lightweight open source standard for securely authenticating and authorizing parties communicating on the network. So this is how it works. It contains three main parts: the header, the payload, and the signature. Do you get me? The header, the payload, and the signature. And it also uses cryptography. So the header is going to specify the kind of algorithm that it is using. Do you get me? There are a lot of algorithms that you can use to sign data. Do you get what I'm trying to say? We've seen we've seen ECDSA, right? Elliptical curve digital signature algorithm, and all those kind of algorithms. There's RSA, there's a lot of algorithms that you can use, but don't worry about them for now. So now it's going to like tell you that, okay, this is the type of digital algorithm that the person is using. Then the payload is the data of that user that is attached to that particular token. That's the payload. Then the next thing is signature of the system that issued that JWT. Do you get me? So now let's say I want to authenticate with Mr. Sam. Mr. Sam has to send me three things. First, the header, which contains the type of algorithm that was used to calculate the JWT, right? Then also the payload, which is the my information, right? Then Mr. Sam's signing those header and payload. Do you get what I'm trying to say? So that's how it works. Then last thing, we also have secrets. Secrets are digital credentials that contain sensitive information. Examples are private key, password, private keys, private certificates, passphrase, authentication tokens. They are secrets. Anytime you get those secrets, they are sensitive information that must not be shared with anyone. You get what I'm trying to say? Secrets, they must be what? Kept to you. Secrets must be kept to you. So it also applies in a computer system. That's why I say don't share your passphrase with anyone. Don't share your private key with anyone, right? So that's it. So how do you now manage secrets properly? That's where we have our secret management. Under secret management, you need to know that secrets must be protected to protect the system and also the information on the system and also the user, right? So there's a difference between protecting the system, protecting the information on the system, and protecting the user. Let's say you want to protect the system now. Okay, maybe you want to prevent downtime, right? So if someone should have access to your private key, the person can log into the server and shut the system down, right? So the system is not protected at all. The person can also log in and delete information on that system, right? So that's another thing. They can also attack users on that system. Maybe they can also steal their funds, expose their sensitive information. Maybe are dealing with a medical record system. Do you get what I'm trying to say? So just imagine someone leaking your health record online. So that's why you should be very careful with secrets. And as a backend developer, you have to work with these secrets from time to time. Do you get? It's not advisable to store secrets on the front end. Do you get me? Because anyone can just check the HTML source code and retrieve it. Do you get? Most times we only store public keys on the front end. So now the next thing is store secrets in a secure manager. You can use hardware keys. You can see people using all these hardware keys. Some people using hardware wallet and stuff like that. So those are examples of hardware keys. They also have hardware tokens and the likes that you can use. Also, there was a time we were trying to claim some funds from L2 Faucet, right? They asked us to use our iCloud to authenticate. So those are some of the things you need to know about secrets. So you have to store a secret in a very secure place. You can use your hardware wallet instead of writing it on paper that someone can have access to. Another thing is regularly rotate and revoke secrets. So now if you are using a secret and it's okay, I've been using this secret for like some days now, let me just try to change it. That's why this actually always change your password from time to time. but it's not always easy, honestly. You can even, during the course of rotating secrets, you can end up logging yourself out of the system forever. So you have to be very careful with that too. So there are some tools that help you with rotating systems. There's AWS secrets managers and the likes that help you to automatically rotate secrets. So if someone should have access to your secret now, the moment you rotate it, it's not working again. Do you get what I'm trying to say? Then revoking secrets. Let's assume you have an employee that is no longer working with you. So one of the best things, the moment they no longer working with you, you have to revoke their access. You have to move their private key or public key from your system so that they will not be able to access anything on the system. Then also implement access control to prevent unauthorized access. Access control is beyond using computers, it's beyond computer system alone. Do you get what I'm trying to say? It's beyond computer systems. Even physical access control is important. Don't allow anyone into your server room. Don't allow anyone to, don't leave your system unlocked while you are away. Do you get what I'm trying to say? Those are some of the access control you can also implement. Then another access control when it comes to computer system is you can set different permission level. You can have users, you can have admins, you can have super admin and the likes. Do you get what I'm trying to say? So you can use a role-based access control. Do you get what I'm trying to say? So that their private key or their public key will not be able to access all the information available within your system. Do you get what I'm trying to say? If someone is a driver now, a driver within your organization does not need access to maybe like company work drive. Do you get what I'm trying to say? You just need access to maybe their mobile app to report from time to time that, okay, this is where I am and stuff like that. Why give access to the old company's record to a driver? Do you get what I'm trying to say? That's how it works. Follow best practices. Avoid uploading sensitive file to repo. Even if it is a private repo that only you have access to, don't upload your private key to it. Do you know why? Tomorrow you might decide to open source it. Tomorrow you might have another person collaborating with you on that project. Do you get? So that person will see what your private key and other secrets are. So also make sure that you use git ignore. Yeah, this git ignore is very important. When you are writing code and you have maybe like a .env file and you don't want to push that .env file online, what you can do is you can use what? Git ignore. So anytime you are pushing, you don't accidentally push your .env file online. Another thing is that when you are building containers, as a backend developer, we work with containers, right? When you are building a container, then there are times whereby you have .env in that same folder, and because the way Docker works, it's going to copy all the files on your system, try to build a new container with it, right? So in that process, you can also copy .env file with it. Then, during the process, you can share that Docker container with different folks and the likes. And from there, they will be able to access your .env file. Do you get? So it's just better to use git ignore and also Docker ignore. Do you get me? So that's why it is important. Always also make sure that you don't use file-based storage for your environment variables. Always use what? Always use what? Which one is better? Is it to use system what's it called, environment variables, or just all inside a file? Yeah, it's better to use the system, the one on your system, right? The environment variable provided by your operating system than to just use a file. I think I'm trying to say. So if you use a file, you can store it in .env, and that is in case of any attack or stuff like that, your file will just be exposed. You get, even maybe due to server misconfiguration. There are sometimes maybe your server has been misconfigured, maybe by an admin, and you are suffering from a problem like directory browsing, whereby all your files are listed online. I will show you an example too. So you can see your file listed online. Anyone can just come and have access to your .env file because your .env file is stored as a file under your system. Do you get? So that's the problem with using file-based .env. Thanks for listening. So let's try to do some coding. If you check this file, you see that I have some codes. We have lot of codes. We have this is going to be like the longest code we've done since the beginning of this program. But don't worry, it's going to be fun. So we are using a lot of libraries. We are using, yeah, yeah. Yeah, authentication is never fun. Yeah, that's true because it's like the main authentication is like the backbone of your system. Once you get it wrong, every other thing is what? Wrong. Do you get? That's why it is not fun. Mr. Bassett, allowing a user to delete all your database. That's not correct. That's not okay. So what we do now is that you see we have .env, EJS, we have itas.js, we have Express. What was this? This is a mistake. We have JSON Web Token, we have SQLize, we have SQLite 3, we have Validator. All of them, we are going to use them one by one. So don't worry, it's going to be fun. So let's create a new folder. Let's name it what? Practice. Right? The next thing we do now is we are going to navigate to the practice folder in our terminal, training 22 what? E/practice. Okay, so what we do is that we initialize a project. How do we initialize a project? How do we initialize a project? No, I want to start a new node project. Yeah, that's great. Awesome. So that's awesome. So the next thing is I don't want to the stress of restarting the server multiple times. Today we are going to write a lot of code, right? We will restart the server. So let's install .env, right? Let's say, how do we install that one? npm install .env. So let's save it as a dev dependency, right? Save dev, enter. So yeah, it's under what? Dev dependencies. What's the next thing we have to install? Express, right? Express. Yeah. We're using what? What? NodeMon. Oh, yes, we are using NodeMon too. Oh, sorry. Yeah, we are using NodeMon. Let me remove this .env for now. Don't worry about this .env for now. So let's add NodeMon as a dev dependency too. NodeMon. Yeah, that NodeMon is going to help us restart the server from time to time. Let's use NodeMon. I've added NodeMon under dev dependency too. You know why this is under dev dependencies? Can anyone tell us? Let me try and get someone online. Yeah, Eniola Kelvin, let me unmute you. So can you tell us why we are saving both NodeMon and .env under dev dependencies and not under dependencies? Eniola Kelvin, are you there? Okay. Can anyone tell us physically? You can drop a text. Yeah. If you know the answer, you can drop a text. So can anyone tell us why? Can anyone tell us why? Who is this? Okay, yeah, Daniel. Let me unmute Daniel. It seems Daniel wants to say something. Oh. Daniel, yeah, you can unmute. Hello, Daniel, are you there? You can unmute. Oh. Hello?
Hello.
Yeah, we can hear you. It seems the network is a bit bad. Can anyone tell us physically?
Hello.
Hello, are you there? Eniola Kev, you can
Hello?
unmute if you can. Oh. Danny is having problem with his network. Let me try to disable you. Okay. Another Kevin can unmute. Okay. Yeah. Why are we using why are we saving node mon and .env under dev dependencies? Yeah. No, that's correct. Mr. Sam said something now. He said everything you see under dev dependency are meant for local development. Once you move to production, you don't need them again. Do you get? So these are tools that we use for development. We don't use them in production. And the main reason why we are not using NodeMon in production is because we are not coding, right? So there's no need to automatically restart from time to time. Then also, we are not using .env because we are not storing our environment variables inside files. When we are in production, we are using what environment variables. Do you get? So that's it. It's going to be stored on the operating system or a secret manager. Any question? Any question? No question, right? Yeah, we are, but we've not gotten there at all. We still okay. Let's not be scared. Okay. So let's move forward a bit. What we want to do next is that we want to add some folders based on the MVC framework that we talked about the other time, right? You can still remember MVC, right? Model, view, controller. Clap for yourself. So let's do the first one we'll be adding is let's add the model, right? Then after that, we have what? The views, the folder. Then the next one is the controllers, right? Controllers folder. Okay, controllers. They're just folders, so don't worry. It's just you can decide not to go with this naming convention. You can start your own, which is really great. Yeah. So let me say the first controller is login controller. Controller.js. What I would do is that I need some things like to put some things in place before I can start using this controller. Do you get me? And the controller is just a function that accepts a request, right? And return what? A response. Do you get me? So don't worry about the big thing that, oh, controller, oh, this might be difficult. No, it's not. So let's have a function, an asynchronous function. What we do is that we have it like this, asynchronous function. Then let's give it a name. What should be the name? Login controller. Okay. Yeah, good. But we are going to take two parameters, right? The rest and the what? Request and this request, comma, this is response. Do you get me? Any question, please? Do you have any question? Okay. So once we are done with that, this request now is going to be the one containing all the information about the request. Then the response is going to be the one we send back. So for the request, when you have a request, you have to think about what kind of request would user be sending. That's the first question. What kind of request, right? In this instance, we're writing an API, writing APIs. We need what? JSON, right? Which is very, very flexible to work with. So you know that you'll be dealing with what? JSON requests. Do you get what I'm trying to say? So the body is going to be in JSON format. And one thing is that by default, it's not going to be passed in JSON format. You have to find a way to set that up yourself. So let's create our index file first under the practice folder itself. So what we do is I will add index.js, then we import express, right? Say once express is equal to what? Require express. Then once you do this, the next thing is to start the app, right? Const app is equal to express. Then you can say app.listen. Where do you want to listen to? Port. Let's use a new port today. Let's use port 10,000. Then you have the callback, right? Which is just any, maybe you want to console log something on screen. Console.log server started. And that's all. Now, but we've not added any view. Yeah, we need to zoom in. Okay. So we've not added any view, right? We've not added any endpoint, right? So we are not going to do that yet. Let's do something first. Let's do, because of the way this thing is, we can say app.use. What are we using? We're using express.json. Because we want this thing to be able to handle JSON requests. You can try to say. So once you do that, it's going to have ability to do that, to handle JSON requests. If you don't add it, you see that when you send something from Postman, it might not really work. Do you get? So let's move forward. Let's now do what we always do. App dot a login endpoint, should it be get or post or delete? Yeah. Should login endpoint be okay? Sir, we can't hear you again. Sorry, is it just you or everyone? If you can hear me, please send an emoji, please. If you can hear me, please send an emoji. Hello? Okay, who is this? Someone is laughing. Okay, don't send a laughing emoji. So what we do now is that app, Abby. App dot what? Should it be post? Should it be get? Please drop the answer in this thing. In the post, Abby. So it should be post. Then we need the path. The path should be /login. Do you get me? But what kind of login are we using? Email, right? So you can see /email. And the reason I'm doing this is because I want to have different login methods. I want to have login with email, login with wallet. Do you get? I can even have login with other methods. You get what I'm trying to say? So, but let's have the login with email for so we can understand how authentication works. The basic flow of authentication is collecting data from the user. Once you collect the data, you do something called data validation. Not every data you see from the user will be valid. Do you get me? So just imagine a user sending Abiola at I. Is it a valid? Is it a valid address, like an email address? Is a valid email address? Is a valid email address, actually, but it's for local host, local environment. Or if you are working within an organization that uses maybe like a custom domain. Do you get what I'm trying to say? So it's possible to know at .com, .org, but on the internet, it's not a what? Valid domain. Do you get what I'm trying to say? So now, when you see someone submitting Abiola at hi without .com or .org, .ng or anything, you don't need to even bother your database. You cannot automatically just reply that invalid what? Email submitted. Do you get? And what if the person does not even submit any password at all? Empty password, invalid what? Password, invalid credential. Do you get? So that's the role of validation. You validate data before you now query the database that, okay, if the data is valid, does this user actually exist? Do you have a user called Abiola with password 1234567 yes or no? Once you have it, oh, good. EU what? Token to that user. What kind of token are we talking about now? JWT. Do you get? A user comes in, submit data, you validate the data. You now what query the database to check whether it actually exists, right? Then now, if it exists, we return back a JWT. So that JWT you apply is called an access token. Do you get? But don't worry, we still continue on our path. So let's have our basic setup first. We seem to add Monty for NodeMon. Let's add the dev for NodeMon. You can say node NodeMon index.get, right? Which is the entry point to our application. The next thing we have to do now is check them. Okay. The next thing we have to do now is to start our controller. So the first thing is that when we have a request, right, we have to find a way to retrieve those data from the request. How many data are we getting from the user? Just to write the email and the password when it comes to login endpoints, right? So you can have something like this: const email, comma, password is equal to request dot body, right? So you can get both data from the user. So what I will do now is that I want to do something. I can say module dot is it modules dot export is equal to this. So this one now we've exported it, right? Right. So what we can do is we can import it inside our index.js as a function. Let's say const login controller is equal to require controllers slash login controller. Yeah, they can hear me. They can hear me now. Like I said, I can hear you. Someone said I can hear you on the. Daniel can join and can leave and join again. Sorry. Okay. So let me try to check one of these. What is it? Yes. Sorry, module.export. Sorry, yeah. I was thinking of it actually. It's module.exports, not the other way around. Yeah, sorry. Kind of very familiar with export this thing. Yes. Yeah. So module.export, this is going to export this controller for us. Then we can use it here. Then let's just put it here and see what we have. Which is nice. You see the way I did it? So yeah, straightforward. Now the next thing is we can have another thing again. We can also have like a response just for stats response dot JSON and say okay, return response dot JSON message still coding. Yeah, still coding. So yeah. So what I would do is that I would say npm run dev. Let's see whether the server will start. We're having some problems with the server, right? Cannot find the modules controller slash this dash slash this. Why are we getting that error? Okay, let me try to import it again. Yeah. Yeah. What is it? What? Yeah. Okay, slash first controllers And I don't think that's why. Login confirm. It's not, that's not the reason. Well, let's try it. Sha. Okay. Is it correct? Let's try to restart this node mount server. See, still can't find it. Cannot find module controller, blah, blah, blah. So let's restart. Controllers. Is it in this folder? Yeah. Yeah, I want to check. This is it. Ah, this is not EX. It might not work. Let's see. But it might not work. Let's see whether we can use that kind of approach. It's about the file part. Do you get what I'm trying to say? It's about the file part, not the controller itself. So I think you should have something to your package.json so that I can start using the heart, all this stuff. Let me just copy it. I'm coming. Let's just copy it to this root folder and let's avoid importing from here. Yeah, okay. Let's see whether it works now. Yeah, yeah, it works now. So let's just deal with this one first, then we move it to the file later on. Okay. The next thing for us to do now is we need to test it with our dear Postman, right? Once we test with Postman, what we'll do is let me check. Okay. Let's send a post request to the endpoint and let's see what we have. Preview. Nothing. Nothing is showing on the screen. Close this. Okay. Nothing is showing on the screen, and that's because let me check the ports. Yeah, the visibility is private. So what I would do is I will change my visibility to what? Public. You see, I've changed my visibility to public here, so I can have access to it publicly. So if I send that same request again now, I'm expecting to get a response. You see, still coding. So it doesn't have to be this thing. So now let's now move forward. So now, what do we do? How do we start the process of validating this data? There's a library we can use. It's a very popular library. It's called Validator Library. So let's import it. npm install validator. npm install validator, right? So I've added, let me navigate to that same folder. Training 22B practice. Okay. Let me add validator to the folder. You see this validator is there now. So how do you use this validator? We can use the validator to check if the data we are getting is actually what we are meant to get. Let's say if email, that means if the email is not undefined, right? But if not, that means if it is undefined, then this should execute the line of this block. So you can see that if not email, if the email does not exist, what should you do? You should return a response that with the status code what 400 .json, like okay, message email not found. So let's now try to send that same request again. Still coding. I think we have the email feed here already because I've tested it already. So let me remove the email feed and let me send that request again. Can you see that we are getting what? Email not found. Do you get? So, but this is not just enough. Let me show you one thing here. So let's assume I have dev at BIH or dev, just dev is enough. And I send that dev. is working, right? Can you see it's coding? But that dev is not actually a valid email. For us to verify, you can say if it's email, right? Or something like, we have to find a way to validate that email here. And that's what the validator library will help us to do. Let's import the validator library. Const validator is equal to require validator. You get me? So if validator dot is email, you can see there are a lot of things you can validate using this validator library. So if not is valid email, or if not is email, then it should return what an like a message that is not what valid. You cannot say return error 400 and email is not valid. So these are what validation. So let's now go back to our, let's send a request again. Can you say email is not valid? That's what we are getting. But if you change the email at bih.com.ng, let me send the request again. See, still coding. So that means everything is working perfectly the way it is meant to be. So we can also add one more thing. You can also verify password, right? If validator.strong password, so validator dot is strong password. So that means the password is a very strong password that we can use. But the other parameters we can also set. Let's just pass the password. So if it is not the valid password, that's when this line of code should execute. So let's copy this thing and paste it here and be like, if password is not strong or is weak. Do you get? Password is weak. So what we do now is, at this point, we go back and send a request. See, it's still coding, right? Because the password we're using is very strong. But let's now change something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Although it's very long, let's even add 1, 2, 3. Let's try to send. Password is what? Is weak. So this is going to protect our application, our users from adding weak password. Do you get? That's how it works basically. So let's choose a very strong password. A strong password consists of capital letters, small letters, symbols, and numbers. You get? So let's send it. You see that it is still coding, which makes the application to work perfectly. The next thing we want to do now is we want to verify from the database, because we've done the validation already. We validated that, okay, the data coming from the user is actually correct, right? It's in the right format we want. So that's why we now have to start working with models. Do you get? So start working with model. Let me try to remove all this controller, blah, 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 that I did earlier. Let me try to remove all this. I'm still going to add the view back. So for this one, let's just add something like a database. But yeah, so this database is going to be like our database, is going to like serve as a connection for us. Do you get what I'm trying to say? So like a bridge between the application and the database. So there are different databases you can use. You can use MySQL. Yeah? No, I didn't. Is there? So there are different. We can use relational database, right? You can use relational database, RDB, and you can use what? Non-relational database like MongoDB. Do you get me? When you're talking about relational, you're talking about maybe Postgres, MySQL, you're talking about MariaDB and the like. Do you get what I'm trying to say? So, but for the sake of this tutorial, we're using relational database, and we'll also be using SQLite, which is it's very easy to work with because it's file based, and also you can turn it into memory based. Do you get? So you don't need to worry about installing database on our system. Do you get? It can just store data on a single file. Do you get what I'm trying to say? So what we do now is that we're going to install the SQLite 3 library. So once you install it, you'll be able to work with. Then the next thing, you can also install the for the modeling for the network is gone. I think people online not hearing us properly. Okay. Let's say install npm install what? Sequelize. So once you install these two packages, then that's all. You have to now create your model. Let me copy an example from here. Okay. Yeah. Are you guys with me? Sam. AJ. Okay. So this is what we need to just set up the database. You can see that there's SQLize here, right? There's data type. You don't need this data type actually. Not meant to be here. Let's remove this one too. It's not meant to be here. So what we do is that we import SQLize, then we pass in some parameter to it. What dialect are we using? It's like this is like a driver for this. If you are using MySQL, you have to put what you are using the MySQL, and if the storage is memory, just put memory. But we are using what? What are we using? SQLite. That's why we added on SQLite, and we export it as a database. So the next thing is for us to now initialize this database and also to set up our models. So for this one, I've set up a very simple model here. You can see that we have the library, we added data types. So let me just do this first. I'm coming. Let me scroll down. Okay. Okay, let's add a new model. Let's name it user model.js. We're going to import this our database here and using our code. You can say this database. We're going to import it in your code. This directory. I think the main problem we had the other time is that we didn't have /, have we? Okay. Yeah. So what we do now is that we add database. Then from here, you can create different models. You don't need to worry about writing database query. This is going to abstract everything for you. Do you get what I'm trying to say? So you don't need to worry about database code. You can just define your user like this. Database.define, SQLize.define, depending on what you are using, then set the data type and other simple parameters. So let's go to database. Let's go to our user model. What would you use? Database.define. Then what are we defining? What's the name of the model? User what? User model, right? Then you can now start defining each of them. So what is the first thing we want to define? ID, right? So the ID is going to be the because the ID is the primary key, right? There's something called primary key in database. We also have auto increment. Primary key is the identifier, like the main identifier for that table that you are working with. For example, now if you have a table of students, their primary key can be their matric number. Do you get what I'm trying to say? The primary key are also very unique. They are always unique. So two people cannot have the same primary key on the same table. It's always unique, but it's different from unique key. There's another one called unique key. Now, let's assume that if you have a table and it contains user data, you can have ID, comma, what's the next thing? Username, password, and email. But one thing you have to know is that email should be unique to each user, right? each user have what? Different email. So that one is what? Unique key. Do you get? The email is unique key, while the ID of that user is primary key. Do you get? So that's how it works. Now, for this, let me go and check the user. You can have the type, which is the type auto increment, and okay, so let me come here. I'm coming. So this is the type. The type is the type of data you are storing inside the ID. We have different data types. You can use characters, you can use integers, dates, and the likes. Do you get? But for this one is what? Is integer. So you can say data type. We have to import it from this SQLize library. So you can say data type dot integer. Then you can say what? Primary key is true, because this is going to make it the primary key of that particular table. The next thing is auto increment, which is what? Also true. This auto increment works like this. When you store a record, a new record, you don't need to worry about adding the ID yourself. Do you get? It's automatically going to increment it from, by default, is 0. It's going to add it to 1, 2, 3, 4, 5. Also, you can set something called the auto increment interval. Like maybe you don't want your own user to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you get? You can have something like, okay, the first user is 1, the next one will be 11, the next one will be 21. Do you know what I'm trying to say? You can set it based on what you want. But by default, it's going to increment one after the other. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. So that's how it works. The next thing is now the email. Email is very simple. Email feed. Just say email. Then you can say data type, because it's just a text, right? Data type dot text. Okay, dot char. So what's the difference between char and char and text? An object, have you? Oh, why are we not making that an object? Because that's a very good question. Because we are not setting more than just this parameter. Do you get? So there's not as if we are setting as unique yet. We still have to make it later, because you have to set as unique. You get? But for now, it's just like this. So the next thing is, what's the difference between char and text, Abby? Text is longer for like, is what's more compact. You get what I'm trying to say? So we need to store some that are not really too long. If you want to store like a blog post, you should use what? Text. Do you get what I'm trying to say? So let's use char for this one. Then the next thing is password, right? Password data type dot char too, right? And what other thing do we need? For now, we don't need anything else, right? Address, we've not gotten there. So people wonder why are we using address? No, we just need two data, like the email and the like, oh, like maybe like an e-commerce platform, right? Okay. Or the address of the wallet. These are okay, like physical address. Yeah, you can also add that one too, depending on what you are building. Let me check some comments from online. Okay, no comments. So let's continue with what we are building. So now, but there's a problem with this email, the way we set it up. See this email here, right? It's not going to be unique. Meaning two people can have the same email with this kind of setup. So what can do is to prevent that you can have what? Something like this. Let's make type is equal to this. Then you can say unique is equal to what? True. You get me? So we'll be able to define our user model. I'm coming out to like, okay, check, okay. So one thing is that now next is for us to export it so that anyone, any file within our application can also import it and use it. Do you get? There's no extent of defining this model without using it. Do you get? So what now is const, I think user model is equal to this. Then you can now say module dot exports. Can now say module dot exports. Module dot exports is equal to what? This user model. So that's the model part. So now, instead of worrying about writing SQL commands, setting up your database manually, this is going to abstract everything for you. Do you get? So that's it. So you don't need to worry about stressing yourself again. Next thing is, how do you now use it? Now, let's go to our login controller, right? You can just come to login and say user model. Let's import user model. Let's import it. I've imported it. User model dot find one. What do we have to find? Find one, right? We're going to find just one. Um, yeah, yeah. No, by their email and password. Yeah, because this email and password the person is submitting to us. Do you get? So we can now say find this where can put where email is this submitted by the user. You get me? So you don't need to like do any stress. So this is it. This is all we need. Where email and password, right? Because it's going to make it like this automatically. So it's equivalent to saying something like this. This one is just redundant. You can now say const user. So now, how do you now know whether the user exists or not? User, if user exists, right? Or let's say if that user does not exist, what should you return? Return response dot status for what? I think for the right? Dot for one dot JSON. What should be the response? Message invalid credential. You get? So if the user does not exist in the database, we are going to return back this message. So let's try to check it now and see what we have. It's not going to work yet because we've not started our database. So for us to do that, we need to initialize database every time the app starts up or refresh. So for us to do that, let's go to this. Oh, did I remove the index for this code? Is that what Mr. Sam was talking about the other time? Oh, let me try to undo that. Cancel. Oh, it's gone. Okay, it's going to be really, really problematic. So what we can do now is that we can just import our database, this one. Okay, copy it. Come, let's go to index.js. Oh, wait. But I can't find it in here. That's what I'm really concerned about. Okay, anyway, let's just say database. Oh, wait. User model. Oh, I'm trying to understand this. I don't think it's in this commit. Did you see me when I removed it? Sorry, Mr. Sam. Let me check our commit history. From I don't think I committed this at all. It was there before. It was there before. Sorry. I'm coming. Please hold on. Let me resume recording. Okay, it's dot sync. So this is what we do. Dot sync. That's all. We can have a callback inside this dot sync like this function, maybe like that. Does the same thing like as the console dot log database started. If you notice, the moment we added this dot sync, you can see there's a message there. Database started on this line. Then also there's a new file created for the SQLite 3 database. So now let's continue with what we are doing. Let's try to ping our URL. So I added a query that, okay, find one user, right? Then where email and password is this? So let's try to await this, because if you don't await it, it's not going to actually work. Let's try to await it. And let's try to send that request again. Guys, we're getting what invalid credentials, right? Because the user does not really exist. So this is just very basic. The moment we create a new user, we are going to be able to, query that user from database, and we're going to get a response. So we need a registration endpoint for that. So let's have another endpoint called register. Register. Then we can say registration controller. This registration controller, what it does is very, very simple. It allows users to create this thing, although there are still some things we need to address. Function, registration controller, then we have the parameter REST and request and response. Let's try to copy this. Let's try to copy this. Okay, now let's move forward. So we're expecting that to provide how many information data for us? Just to write the email and the password. That's what we're going to do from the request body. We're going to pass it from the request body. Also do the same verification that we did here, everything. Just like the normal login flow. So I'm not going to write the code again. Let me just copy everything and paste here. The next thing is we can now try to, since all the data is correct, right? We can try to find if the user exists. Let's try to find whether the user exists. If the user exists, we are not going to create the user, right? So if the user exists, like this one, is just going to be opposite of login. If the user can now say user already exists. Big I'm trying to say. So that's it. Now let's go to the registration page. Registration points. Okay. Register. Well, let's try to ping it. We have email and password, right? Let's send. Still coding. I think it's working now. Do you see? It's because showing us was still coding. But if you try to register again one more time, it's still coding. Okay, yeah, we didn't actually commit this change. What would see? We didn't commit the change. We didn't create a new user. You get? Just try to verify whether that user exists or not. So what we can do now is that we can say await user model dot create, right? What do you want to create? The email, right? Comma and the password. We want to insert it into database. So once you do this, you can now say const new user is equal to this. But this is not going to save it in the database. Yes? You're going to do what? New await new user dot save. You get? So I can commit it to the database. Now let's say still coding is working, right? Let's try to do. Can you say it's showing what user already? As the second time we try to submit that same request. So that's how to do your registration endpoint. Registration endpoint is complete now and it's working perfectly. But we still need to work on the user, what's it called, the registration and the login page. But note one thing. See, if I change this thing to text like this and I submit, it's still going to register. Because to our database, capital letter test is different from a small letter test. There's a quick fix that we can do. What we can do is that anytime you want to commit something, always make sure you commit the lower case every time. So what we can do is you can say, let's have a new, this you can say lower const, lower case email is equal to what? Email dot to lower case, right? You get me? Now, instead of committing this email, I just commit this one. Also, there's a mistake with this. We're trying to find user based on username and password together. You should always check for what only the email, whether the email exists or not. So let's move forward a bit and try to check one more thing that we can also change. Let's come here, do the same thing. First, just paste it. Lowercase email. Lowercase email is what we commit to database, right? Let's now save. Now, that error has been rectified now, but there's still one more thing to do. Okay. So now, I will try to send. You see now, user exists already, right? If I change the case, maybe to something like this, test, and I try to send the database, you see, I'm still getting what user already exists. So the next thing we can also do now is we can, after confirming whether the login detail is correct, let's go and confirm whether the login detail is now correct. Is it? Let's say send. Let's visualize. Okay, I'm coming. Login / email. Let's send. Invalid credential, right? Let's copy this address. Let's copy this data and paste it in our registration page. Let's send it. Can you see that we've registered a new user? So let's go back to our login page and try to log in. You see that it's now working. So let's try to remove all those error messages. Login successfully. So something like that, just to know that, okay, it succeed or not. Now, the next thing is, how do we now fix the problem of, trying to issue out JWT? Do you get? So we need to install a library called JSON Web Token. So I'm coming. Let's install that library. Let me copy the name from this JSON Web Token. Let me come here. npm install this. Okay. I'm installing it already. So the next thing we do now is we have to have a middleware. But before we have that middleware, let's try to do something. Let's try to issue out a JWT token first. You get what I'm trying to say? Try to issue it out. But before we can issue it out, we need one more thing, which is like the key component. We need to have a secret that will be used to sign every JWT we issue out. Because you can remember the other time I mentioned something about that JWT contains how many parts? The what? Signature. For you to get that signature, you need a secret, like a private key, right? So what we'll do now is that we have to add a .env file. You can say .env file, right? Then you can say Inside that dot env, you can say secret is equal to something like this. See, just have a random secret, something very secure. Again, secrets. The next thing is, let's go to our, we can try to use that secret that we just added. How do we add it? How do we use it? You can see a .env because a file-based what environment variable. So you can say require .env. When you say require .env, you can say something like .env.config. It's going to load all the environment variable from the file into the process.env object. Do you get what I'm trying to say? So now you have inside the process.env object. Then next thing is that we are now going to try to issue out a JWT token. For us to do that, we need to import the JWT library. Const JWT is equal to require JSON web token. Hey, sorry, JSON web token. JWT dot sign. Now see, hello. This is where we now what need what the main what. Oh, try to JWT.sign, then you do all the basic setup here. You sign, you can see that there's two things you need to sign, what payload and the payload and the what? The secret key. So what's our payload in this case? Username and password, that's the payload. No, don't store password inside it. Just store the user. You can even store the username and email, or email is enough. You can just come and see what email, right? For now, because that's the only thing that we have. Or even the ID, you get, you can say ID, user.id. Where are we getting the user.id from? Here, where we create database, right? So get the ID, then you can say from here, that's where you get the user ID. Then you can say user.email. So once you do that, you can now use your secret key, right, to sign it. You can say process.env.secrets. This is secret is stored here. Do you get? So once you do that, you should get something. You should get the access token. Let me check it out. Once you get the access token, we can return it back to the user like this access token. Let's see what we have on screen. Or do we still need to like convert it from buffer or something? So you see, we have this. Let's now try to send. You see what we have now? Access token. So this is access token on screen, and this access token the user will be using to log in into our application. So let me try to send one again. It's exchanging. And also inside the payload, there are a lot of things that you have to know. Inside the payload, there is the time that this thing was issued, the token you get. Based on that, you can do some calculation, and in your database, in your backend application, if the JWT is older than 10 days, 20 days, 50 days, you can what? Deny access. Do you get what I'm trying to say? But for now, we've been able to get the JWT from the backend, which is quite impressive. Now, let's now add maybe another endpoint. This endpoint is called the profile controller. The purpose of the profile controller is that when you send a request to the profile controller, it returns back user data to you. Do you get of the current logged in user? For us to be able to achieve that, we have to add a function called profile controller. It's going to be an asynchronous function. So you can say async. Then we have what? request, comma, response. Then you see this now. What I want to do now is that, okay, you know one thing, I mentioned one thing about the difference between a middleware and a controller, right? That a middleware is going, you can tamper with, can modify your request, right? And also your response depending. So it's going to modify it. So that same principle is what we are going to be using here now. When the user sends a request, it's going to go to the middleware first, right? Then the middleware is going to catch that request and modify it and also do some validation before passing it to the controller. Do you get what I'm trying to say? So what we want to do now is I want to tamper with the request that is coming in. When that request comes in, we grab the JWT token inside that request. Once we grab it, we now verify that JWT or return back 403 immediately. You can try to say. But once that JWT is valid, what we do is that we just tamper with the request object, then we modify it. We add user, we add user property so that we can use that user property throughout all our application. Do you get? Or during that request life cycle. Do you get what I'm trying to say now? So what we do now is what we do now is that we have to create a middleware. Let's get a new file for middleware. It's almost something like a controller. You see the difference now? Okay, let me copy all this code. Let me explain this. What we are doing is that we are importing the JWT library, right? Next thing is we are importing the .env, which is going to help us with the secrets. Then we are going to define a middleware. That middleware is going to take in two things. The request what? The request that is coming in, the response, and also the next, like so that you can pass to the next middleware. That's why I said what? The other slide, you can pass it to the next middleware using the next function. So once the request comes in, there's something called headers, right? Inside that header, we have different parameters that you can access, like different properties. You have authorization. Let me show you some of the headers. You see, this is where header lives. Let me show you here. You see, this is where header. You can see these headers, right? Different headers. We have cookies. You can grab cookies. You can grab cache control, user agent. This user agent shows you what kind of browser the user is sending the request from. Do you get? So if you need to do some checking, okay, I don't want to allow people using Safari to use my backend. Do you get? You can ban them based on their user agent. But this user agent is very tricky. You can't really rely on it because some people can manipulate it. So as accept encoding, what encoding do you want to accept? So gzip and deflate. These are just compression algorithms. Then the next thing is connection, keep the connection alive. So that's one thing. So there are different words, different headers that you can use. There are a lot of headers, even more than this. If you're using the web browser, you'll be able to see more. Like, okay, where do you want your referral, your all those stuff? They're also part of the header. But the only header we are concerned with is authorization header this time around. So once we get the authorization header, this process is not really needed. Don't worry. You can replace it maybe if auth header, blah, blah, blah. Don't worry. But just so that this auth header that we are getting, I'm just trying to validate, okay, is it not empty? Do you get? If it's empty, if it's not empty, then split it. Why are we splitting it? In web design or anything code, you always try to follow standard. Do you get what I'm trying to say? Standard. The standard is that when you want to pass authorization header, you pass it in form of like the kind of protocol you are using, right? Maybe bearer, maybe token based or get. So it's going to be the P, then the JWT is going to follow it, or any access token you're using. So I'm going to do an example later on. But once you get that token and it is empty, then return what? 401. You get what I'm trying to say now? You return what? 401. But if you try to verify it, and it is what? It is not valid, or there's an error, return 403 unauthorized. You get what I'm trying to say? How do you now verify? You say JWT, then you pass out two things, the token and the secret key that was used to sign it. So now when you now sign it, when you want to verify, it's going to like, you are going to need a callback again, right? That callback is going to be the one responsible for the passing it to the next middleware, or returning what? Error 403, or any error you want to return. Do you get what I'm trying to say? So you see that this one now is say send status, right? You can also change like send something, maybe send, or let me say status 403, right? Status 403, then I can say dot, yeah, JSON, then you can see what, maybe you want to provide more information, like okay, message invalid. Okay, big I'm trying to say. So now once you have this middleware set up, the same approach, what we do is that we, okay, sorry. Okay, yeah. Let's just pass this let's pass this middleware, auth middleware. So we need this auth middleware now. We have to export it. Then we use it in our request, in our, what is this? We use it here. So this is what we do now. App.post, then profile slash profile, right? Because the profile endpoint is, that's to be authenticated before you can access it. You know what I'm trying to say? If you are not authenticated, you cannot access the profile endpoint because it's not going to return any data to you. So I'm going to pass in the middleware. Is the auth middleware? Let me import the auth middleware from here. Const is equal to require. You get me? Sorry, let's use middleware. The name of the file is middleware. You get? So we are importing it, then we can now use it in our app like this, then say comma profile, which is profile controller, right? But you are rest assured that if the request can get to this point, if the request can get to the controller, that means the middleware have done most of the work already, right? The middleware have verified the data inside the payload that is correct. That's why you are here. So now you can now be rest assured you can return a response with what? Status what? 200, okay, right? Dot what? JSON. And this JSON object can just be the request. Am I even connected online? Hello? Okay. So can you guys hear me? If you can hear me, please send an emoji. Okay, they can hear. Thanks. Try to copy this. Let's connect. Sorry for that. We have to reload the workspace. So if your request can get to the controller, that means the middleware have done most of the work, right? Of verifying whether the JWT is valid, right? So that's the authorization aspects. Now let's move forward a bit. What we'll do now is that that's a request.user. It's going to return the data stored inside the request.user object. We modified it inside the middleware, right? We can now go back to our postman. Let's go back to our postman and sorry for that, still waiting. Let's try to start up the server again. What I will do is that I will go to CD, practice, CD, yeah, 22B. Okay, npm run dev. There's a problem. There's an app using that port already. So let's try to change our port to port 5000. Let's see run dev. So we're now running on port. Oh, 5000 is also in use. Okay, let's do port 9000. Yeah, so ports 10,001 works well. So let's change our address to 10,001 and let's send the request to it. If you send the request to the profile endpoint, you see, we are getting what? We are getting 200. Let's visualize. No, it might not be, it might be an error actually. What are we getting? Yeah, we've not forwarded the port to get it's private. Let's make it public. Change visibility, public. Do you get? Let me try to send the request again. It should return for or something. Error. Review. Let me get the updated address. Okay, let me remove the ultimate URL first and see what we have. There's a problem with the ports we are using. Let's switch to another port. Sorry. I think this port is stable. Let's make it public. So we're having port problem now, not yeah. Cannot get slash profile. Why are we getting this error? Oh yeah, there's a problem. The problem is that we added what post instead of get for the profile URL. Sorry, it should be get, not post. Let's send get request, and we should get a message or anything at all. There's a problem with this our node mon. Yeah, we're getting an error with the port number every time we try to restart. Telling me every port is in use. This is a port error, not. Let's use port 5050. So get this error. I think I might need to restart the whole. Okay. Yeah. Sorry for the delay. Let me copy this. Let me do slash profile. See what we have. And you can see that we are getting what? Unauthorized, which sounds really great. Sorry for the delay. And let's go to our body here and also send the same request, 3,000. You can see I'm getting an invalid token. This invalid token, that's because the token is not valid. And if you go to authorization, the header, you can see that the bearer token I'm using is not valid. What I would do is let me delete this one there and add a new one. So what the first you have to do is add the authorization header. You can see authorization, the type of authorization I'm using, bearer, then followed by the access token. So let's change the new access token. Okay, let me use port 3,000 in the ports. You see, we get a new access token, right? So I'll copy this access token. And what I will do is I will come back to my profile, the authorization header, then I will add it after the bearer. There should be a space after that dot, and I will say what? Send. You can see that I'm getting what? These three information. I'm getting the ID, email, and the issued at timestamp, issued at timestamp. So this timestamp when the token was issued. Can you see that's how this thing works? So we've been able to set up the three process like the. So let's try to modify something, maybe change this and send. You can see that the chain was invalid token based on the message we set earlier. So if we didn't send any message, you just see unauthorized access 403, but it's showing us for 200 here because the token is correct this time around. Now, that's just for the password authentication. We were able to set up password authentication, email and password, right? I'm able to set up the JWT, right, for authorization. You get what I'm trying to say. Then next thing we want to do now is that we want to also add sign in with Web3 endpoint, whereby someone can sign in with their wallet to any backend application. So that shows that we're using the cryptographic what method, right? And not using just the conventional way. Then the next thing is we need a before we can do this, we need to set some things in place. But let's start first with the login controller. Can you see that this is login controller, right? So, but we have to add another controller again. Async function login with wallet controller. You get me? Login with wallet controller. What we do is that in this kind of scenario, the user must have a wallet connected to their account when they register, right? So we need to this will change the whole architecture of our database, the design. Do you get? So we need to add the address column in our database. Do you get what I'm trying to say? So what we do now is we have to go back to this user model and let's add one more thing, address, right? But each user must have a unique address because you cannot use the same address on two on this thing. So you can say type data type or the what dot unique. Is it not char? It's character now. ABC 0x. I think we are missing something here. Okay, we are good. The next thing we have to do now is let me check any question online. 301. Okay, okay. Thank you. Now the next thing now is we've modified our since we modified our model, we also need to modify our registration page, right? So when they want to register, they'll provide their address they want to log in with. Okay. So let's move forward. Why is this thing popping up every time? Let's move forward. Let's go to our index, right? Should we move this code to like different folders or different? Yeah, we should move it, Abby. Okay, let's move it now. We are going to move it to controllers, Abby. Controllers page, so that each of them can have their own file. So we can even have something like login controller. So under that login controller, you can have two type of controller, right? The email and the this thing. So anything concerning login, just under the login controller. So now let's move this one, this login controller, and the other one, let's move it to this page. Do we need that? Do you have any dependency? We have JWT, right? Which is it won't work without this. We have to import it. Let's import it now. I'm coming to my index.js. Can you see now? Let me cut. I'll go to my login page and add this new one. You get? Then I can now say module.exports. What are we exporting? Two things, right? That's why we added what? The object slash login with wallet control. So this thing, it doesn't sound really nice. Let's say login with email controller, do you get? And login with wallet controller. So this controller, I can put this one here and export it. If we export it, we can come back to our index. I think we're still missing one more thing. We are missing the .env, right? Because we're using .env here. Let me show you. Because we are validating something here, you see. You see, we are using the process.env.secret, right? We need to import this one, then say .env.config, right? For it to work. That's it to not work. Now, the next thing is, let's move to this page, the index page, and also look for one more thing. Let's try to change this to what? log in with email controller. It's going to automatically import it, you see, dot controller slash this. Then the next thing we are going to do is app dot. Should we add that one now? Okay, let's leave it for now. Let's go back to our controller. Let's add one more controller. What is restriction controller, right? Do you get? So I add restriction controller, then I'll move all my code under this registration here to the registration controller. Where is it? Okay. But there's one more dependence that we missed here. Validator. We are validating using validator. So validator is not imported in that file. So we need to also include it, else it will throw error. We also need user model, right? Which we have not added. So let's add those key components. Everything that you use, you have to add it. Else there will be error. Same thing with this one here. We need to import these two, validator and the user model. The two. Do you get? Once you imported all these things, I think the controller is set now, is working perfectly. We need to just import this registration controller. Let's say export it first. Let's go back and say modules, right? Module.export is equal to registration controller. And from here in our index, we can now import them like registration controller. We've imported it like that. But one more thing to go. We need to still modify this our registration page to include what? The logic for validating address. When someone submit address, you can't just allow someone to submit any address, right? But in the validator library, you can say there's if is Ethereum address, right? Validator.is Ethereum address. It works, but it's not enough because it uses regex, regular expression, to validate. But the one in ITAS JS uses checksum. Get it calculates checksum. So that one is far better than the one in this validators library. So that's we will not be using the validator library. So now, what do we need next? We need ITAS JS. So what I will do is that I will come here and I will say npm. Let me navigate. Npm install what? ITAS. So yeah, this is all we need for now. Let's now go back to our login controller, our registration controller, and say const is address, right? Where do we import that is address from? Where that's yeah. So that's his address is what we need from that address. You can see you can use to validate any kind of address. So we also need to assure that the user is passing what address, right? You see, then we can now have one more validation whether the user is passing email. Let's see that user is passing what address too. If user is not passing address, what should be the error? Address not found. Anything you like, it's just grammar. You get. So next thing is also check whether the user is passing a password. We didn't do that actually the other time. It can crash the application actually. So let's check for password too. Do you see? So we're taking all this component. The next thing is let's add the validator for ITAS yes, right? ITAS dot is address. Then let's pass the address I want to validate. Address. Then we can add, if not address, right? If the address is not valid, that's when we want to let this code execute. So let's just do that. Address is not valid. That was all. So, but there's one more thing again. We also need to find a way to lower the address. You don't want to store it because address sometimes when you copy from MetaMask, you see that it's checksum, right? Sometimes it's capital letter, small letter, all combined together. So it's because it's checksum. You get. So now to lower everything, you can just use this JavaScript method and address dot to lower case. See, you can even set as capital letter. It doesn't what? matter. You get, so far that it is uniform. Do you get? So that's what we need, uniformity. You don't want the first one to be capital, small letter, capital letter, zigzag, mixed. Now let's continue. Oh, there's a mistake here. See. Let's try to remove this. Find one. Then we are just finding based on the if the username exists already, or whether the what, whether the address exists already. It's going to like be like two things combined together now. But because we want to create database two times, Abby, we just want to create the database just once. What we're going to do is that we are going to combine those two queries, find whether this email exists, find whether this address exists, right? Before you insert anything to the database. The only way you can do that is by using the or. You can say email is equal to this or address is equal to this. If any of this exists, return what? Address or email already in the database. Do you get? So for us to do that, we can have this where this where is still the same where we are using. Just add one size op. Oh, sorry, op dot or. Is it op dot or? Let me check. It's actually in the SQLizer library. Let me import it from SQLize to be sure. Photo. Wire SQLize. Then you can import the OP, yeah, small letter OP. So operation actually. So operation, which operation do you want to carry out? All right, dot OR or you see. Then we say you can now put it there like this. It's going to be like to be actually. So each of them will now contain. This is a bit like complex, but go and check it. Like go and master this. Because the address. Then what's the address? This address that we are getting from the user, right? But it's going to be in lowercase. Let's say lowercase address too, somewhere around this place. Lowercase of address is equal to address dot to lower case, right? So this is it. And we have this email, right? And lowercase of email too. So if either of them exists now, it's going to return the user. And this is not going to be empty. Then we can now say user email or address already exists. Big I'm trying to say. Now let's now try to also add address every time we add something to the database. Lowercase address. Okay, C is lower, right? Okay. Yeah, but it's different from this. Like this is better. Awesome, thank you. So this is it. We've been able to add what? The address to the distance to our database. So also, when you query the profile endpoint, it should also return back the address of the user. So how do we do that? By using the JWT, right? So just say what, comma, address of what? User dot address. You get me? Or better still, you can use the structuring operator like to destructure the object that you want to send. But don't worry, this works too for beginners. Now, next thing is the profile. The profile endpoint is working already. So let's just move it to its own controller. Let's have it of profile controller.ds. Then we put it here and say module.export is equal to what? Profile controller. Do you get me? Then I'll come here and add profile controller. Okay. The problem is that it's not linking. Let me say profile. Okay, it's not intimate. So now, you see now, everything has been moved and this file looks better and more easier to understand. Do you get? Looks better now. compared to what we have before, whereby everything is just inside a single file. Yeah, separation of concerns. Thank you. So now you see the way we move everything gradually. I know if you put it through work, but it will be very, very readable. Next thing is how do we work with the address, like the address, right? So that when the user wants to sign in, the user sign with their wallet, they send it to our own backend. We get the message user sign, then we verify whether it's from the user or not. That's the next step, right? So to do that, what we have to do is we have to go to our login with wallet controller, which is going to take two parameters, right? The request, the response, Abby. Now, for us to now get a request, for you to sign in using your wallet, you need to send two things. You need to send the wallet and the message, and also the signature. Three things, sorry. The message, the address, and the what? Signature. But better still, might not send the address actually. But yeah, we can find a way to work around that. Let's say message and what? Message and what do we need? Message and what? Signature. So let's use only message and signature. Let's not add address. So when you want to sign in, you send a message and also a signature to the server. So let's now find a way to do it. Message, comma, signature. But that message can be gotten from where? The request, right? Dot body. Am I correct? Okay. Next thing is we're going to return a response. Response dot status 200, right? Dot JSON. What are we going to return? That DWT, right? The same DWT we have here is what we're going to return. So let's just return an empty object for now. How do you now process all these things together? First, when you grab the same way we did then, personal sign, when we are doing the task DS tutorial, the same thing we do now. Do you get what I'm trying to say? Now, when you have a signature, you have to find a way to extract the signer. So you just need to pass two things, basically. The message you are trying to confirm and the signature, the same way we have for the DWT. Anything signature, that's how it works generally. So now let me go back to this practice code. Okay. Okay, it's not there actually. So what we do now is we import it from the ethers.js library. Let's say comma. Let's import ethers.js here. Can say const. Yeah, let's import ethers.js. Let's say ethers require ethers. Give them require what? Ethers. Then once you require ethers, what do we need from ethers? Verify message. Is it verify message? Okay. Yeah, verify message. That's what we need from the ethers. So it's where are we importing it? Wrong place, sorry. Let's move it to what? Our login controller. This is where we put it. Right? So now to verify this signature that it is coming from who, you can just say const address is equal to verify signature, then what pass the message and the signature to it. So if you say return address on screen now, it's going to return the address that signed the message. Do you get? Hello, do you guys get? Now, let's stop at this point and do one more thing. What we'll be doing is the third thing, which is what? The view. We've done the model, the controller, and the what? The view. So what we'll be installing a library called EJS. We mentioned it the other time, right? So EJS is for templating, if you want to like render a template, so what we do is npm install EDS. Come, okay, the same thing. So now let's move to our index.js and let's say what app.use are we using. Let's import the EDS. Let's say const EDS. Yeah, we're going to require EDS. Can we say use EDS? Yeah, is it correct? Okay, let's try it first and see whether we get any error. Okay, so let's start our server. Is server running already? No, it's not running. It's down. So I'll do is what say npm run dev. Okay, it's crashed. Cannot find user.model. Where is that? On okay, can you see? There's no user.model. Yeah, the path is invalid, it's not correct because it's relative, right? You have to do something like this to be able to get the right path. Do you get what I'm trying to say? Then also let's go and check every other occurrence of this same dot dot. Let's check now whether we get any error. What other error again? EJS is not a function. Okay, it's not a function. Then what do? We just pass it directly to it instead of making it what? Wait. Do we need to use it? No, we don't need to use it actually. Let's remove it, please. We don't need to use it at all. What we need to do is that whenever we have the view, we can just render the template. Do you get what I'm trying to say? Based on the stuff. So yeah. So the next thing now is that what do you want to render on screen? Let me go and get what I want to render on screen. What I want to render is the same code we use then for our itas.js tutorial. So I'll go and copy it and paste it here. That code is going to allow us to open MetaMask and sign a message and also return it in the console. So let's now go back and get our views. So this is the code that we use then. But this time around, we are not naming it .html, we are naming it .eds. So we're going to have a new folder. Let's name this folder what? Views. Then we bring it here and say, what's the name? Signer.eds, right? Then we paste the code. Let me go back. The component of the code, although I've made few changes. See the change I've made. The same thing we request for the account for MetaMask. Then we get the signer. Then we get the current state, which is for the timestamp, and also we console log it and we sign the timestamp, and also some basic settings like just console log it. What we did is that we get the timestamp. We prompt the MetaMask to sign this timestamp for us. Then we also get the address. It's just that's what we did here. Nothing too much. Now let's move forward a bit. Now we need to render this template right on screen so that people can see it. But one thing is I'm coming. Let me check. Hello. Yeah, this is it. So just come to this place. This our index.js. Let's remove this. App.set. Then you can say view engine. What? EJS. So that's it here. That's it. Do you get? So this is just the line of code you need. You don't need to import EJS. So just say the view engine is equal to this. And once you do this, it automatically passes the render this into your response. So let's go and do that. Let's have our What should we call it? Wallet signer view controller. Something very, naming a variable or identifying since in program is hard. So just give it something. Function. Let's copy this, rename. Okay, so let's make it asynchronous. Then we can see what? Return is going to be what? Request, comma, response. And we can say return what? Response dot render. So what do we want to render? What do we want to render? That same views slash signer. Do you get that's what we so you can say under views slash don't save it, just say signer. It's automatically going to come here and check. It's going to start from the views folder. Do you get? So don't worry about adding this thing. So it's okay like this. You cannot see what module exports is equal to wallet view controller. So now you can see that this wallet controller is just rendering like a basic HTML on screen. Doesn't do more than that. And this is HTML, but you can't store it as HTML, store it as .ejs. Do you get? So, but don't worry, you can just check out the template online. There are some ways you can pass some parameters to this template, which is going to make it more dynamic. So if I visit the URL, what I will see is different from what another person will see. So, but it's just very basic. Now let's go to our index file and pass a new endpoint. It's going to be a get endpoint, right? Because we want it to be visited from the browser. And by default, browser send what? Get request. So we can do it like this. Signer view. Signer, yeah. I can just say, what do you want to sign? Let's name it wallet signer view controller. Something. The name is scary. So let's change this. Let's try to check this URL now and see what we have. You see that we are getting unauthorized, Abby. Let's go to sign up page and see what we have on screen. So when we go to the sign up page, you can see this on screen, right? So it's prompting me to take my MetaMask and asking me to connect any of my accounts. Which of the accounts should I connect? Let me connect the one with the least balance. Let me do it next. Next. That's all. It's asking me to sign a timestamp now. And JavaScript timestamp is always in what? Always in milliseconds. So can I sign? And that's all. If I go to my index, my inspect mode, I will see an object, and that object should contain the address, the signature, and the timestamp. So these two parameters, the signature and the timestamp. Timestamp can be what? The message. Do you get? So let's go and edit our code to make it more, understandable. Let's go to our login controller. Instead of having message, you can name it what? Timestamp. Do you get? Timestamp, then timestamp is okay. You get? Now, let's now try to copy all these parameters that we have here and send it to the endpoint for the, let's copy these objects. Let's try to send it to this endpoint, the login with wallet controller, which we have not added yet. We have to add it. Login with what? Wallet. It's going to be a post endpoint. Then you can say login with wallet controller. You get? Now let's go back to our browser. Let's copy these objects and let's pass it from here. Where is it? Login slash address. Let's say wallet instead of address this time. I think that's the right endpoint. Slash wallet. Okay. Now let's see what body. Let's change the body. I've added a new body to it. Let me just send. If I send, I'm getting 400 or 404. Where can we see the error log? Let's check the error log, please, and know what error that's facing. Wallet controller is not defined. Yes, it's not defined. And that's because We didn't export it, or did we? Log in with wallet controller is not defined. Did we import it or what? Log in with wallet controller is not defined. Okay. Line 20. It's actually defined now. Why is it showing error? Okay, let's restart. 400. Let's view raw. I'm not getting any good response from this. We're not getting any error message. Okay. I think there's something wrong with the render. I'm coming. There's nothing wrong with the render actually. The render should be fine. Let's go to. Okay. Log in with wallet controller. We exported it. Okay, let's do something. Oh, I think I know what could be wrong. Save this. Let's start. I'll put this. Can someone tell us what's wrong with this app? We are sending to the wrong URL since morning. Sorry. So there's nothing wrong. We are just sending to the wrong URL. It should be port 3000 because you changed the port. Port issue. You see that we are getting this what address back. So now, what this implies is that after the verified message has been completed, like a calculation. Hello, please take note of this part very well. We did the calculation, we pass in timestamp and the signature rights. We now ask the verified message algorithm to calculate what function, to calculate the address that this thing was signed from. Do you get the logic? So without passing the address, we're able to calculate the address that was used to sign the message. Do you get? We didn't pass out the address actually. But let's remove the address so that we can know that it's not because we passed this address, that's why it is working. See, it's still calculating it, right? Because it was able to deduce that this message, it was signed by this address. So based on that, once you get the address, the next thing is for you to now check your database that, okay, does this address exist in my database? Before we now run into the other problem. I'm coming. So what we do now is let's use the same find, this logic here. Let's copy it. What I would do is that I would just paste the same logic. I would say lower case of address, lower case of address. I'll now ask this to lower the address for me. And I'll now say where address is equal to lower case of address. So it's going to find whether this address exists or not. So if it exists, it's going to return this JWT token, the same method, the same flow. The same flow. The only difference is that we are just using the address. So let me paste the user. If not user, if user is empty, that means this address does not exist in our database. It should return what? Error 401, invalid credential. But if it exists, it should what? Return 200 and also the address. But let's say the JWT token this time around, not the address. Let's save. We save. Let's send a request. You're not getting anything. 502 error, blah blah blah. Yes. Yes. Do you know why we're getting this error? Our database structure doesn't align with what we have already. I'm coming. No such column such as address. Do you see? So we have to find a way to commit all these things. Let's delete our former database. This is going to be really. Yeah, there's a way, but we are just testing. So those data don't really matter. So let's run again. and we have to create a new account. Let's go to register endpoints. So you see my registration endpoint, right? If I don't pass address this time around, is it going to work? Okay. Oh, we are using the wrong endpoint. Sorry, 3,000. Let's send. Address not found. But it's optional for someone to actually register with address, right? Or is it not optional? Should we make it optional? Yeah. So we want to make it mandatory, right? If you want to make it mandatory, you can still make it. You get. So if the address does not exist, but this time it's mandatory for you to add address when you want to sign up along with um, your password. So let's get the address from our MetaMask. Address. Hello. Can you see this is the address, right? I've copied it. I'm going to paste it and register a new account. And you can see registration completed. Now, what I will do is that I will now go back to my profile. Let me go back to my login with email, right? To generate a new access token. Because this access token I don't think it will work. Let's send. So we have a new access token. Let's copy it and go back to our profile. Let's change the bearer token there for the profile. You see, I've changed the bearer token here. Then I'll say what? Send. The moment I send, you can see that I get what? All the information, the ID, email, and also the address, all in lower case. Let's move forward. Let's move forward now. The next thing we have to do is we have to also consider the fact that our endpoint here, can also allow us to log in, right? Let's try to log in, send. This time we also get access token where we try to log in from this endpoint because what? We have a valid signature and that signature has been signed by someone that is registered on the platform, right? So let's go and switch our MetaMask and see whether if someone else try to connect. So this someone else, right? Yes, it's recording. Okay, let me now continue to. So the next thing we have to do is that we have to go to our MetaMask. Let's try to switch account, right? Let's try to refresh. This other account, we try to sign with it. I think we have to pen this signature already. So let's try to refresh again so that we will not make any mistakes. So we signed it right with a new account that wasn't registered, that have not been registered on the platform. Let's try to copy it and go to this page. Let's replace everything here. Let's remove this address. Let's remove this comma. Then say what? Send. And it's what? Invalid credential. Although it has been signed by what? An address. But because that address does not exist on our own platform, it's turning what? Invalid credential. But there's a problem. There's a replay attack. See, there's a replay vulnerability in our code. If I send this thing 1 million times, 1 million times, it will keep what? Generating access token for me. Meaning, if someone hijack this my token, they can always generate address. So to solve that problem, we can use timestamp. Maybe once it's 5 seconds or 10 seconds or 30 seconds, this token should not be valid again. So what we do now is that we go back to our code and add the logic to time limits. But for the nonce, we'll not be able to do it today. But when you get to for the assignment, try to use what nonce. The basic principle of nonce is that it stores that nonce inside the database or inside a table in your database to keep track of, okay, this is how I've used this nonce, I've used this nonce, so just have a new model, maybe user nonce model, then it's going to be like a reverse foreign key to a foreign key to the user table. Then there's going to be nonce on that table too. So that's how it's going to work, basically. So what we do now is that we come here and add one more thing, time checking. So now let's come to the top. Yeah. You can now say, if current timestamp that we are right now, this timestamp is something by the user, right? And do something like past int to convert it back to integer, right? And say const past timestamp is equal to what? Past int, because it's in what is in string format when it's submitted by the user. But this thing can also lead to more errors. Like there can be error, right? Because maybe the user passed in letters, right? And you cannot use passing to pass in special characters and stuff like that. Do you get? So if you do some like checking and also try to catch some errors. Do you get what I'm trying to say? So this place is my true error. So when you put in the wrong value. So now past time stamp. This past time stamp must always be lesser than the current time date dot now. But if you do it like this, it's going to be a problem because the time you sign in, you sign the past time must be greater than what? The current time. Do you get? The past time must be greater than current time. That means the time service is in the future. And the only time something is valid is when it is what? In the future. But there's going to be a problem again. What if there's an attack and the user was tricked into signing a token that is valid for 100 years? Do you get? So you have to also consider it like these two. So what you can do is that you just add plus past timestamp plus maybe 60 seconds times 1,000. That's 1,000 milliseconds, right? 60 seconds times 1,000 milliseconds. Now, let's now think about it very well. Let's say we have a time now, right? And want the time, this is to be valid for up to how many seconds? 30 seconds. What we can do is that if you get that date, what we can do is that okay, this is our current time that we are right now. If we had 30 seconds to it, is it greater than or equal to the time that user passed? Let me do some calculations so I can see what I'm trying to see. Let's say the user passed in 100, right? And according to our own, we have what 30 seconds, Abby, window for this thing to expire. And the current time is 120. Do you think that this is valid or invalid? This is time passed by the user. This is the time that it will expire. This plus 30 seconds, right? Then this is what the current timestamp. We still have 10 seconds to expire. Do you get? So that's what I'm saying now. That this thing can see what for up to 30. How can we now put this thing down in code? You can now say that the time passed by the user. Do you get? Okay, let's reverse the logic. Do you get? Let's reverse the logic. You can set our own current timestamp. This dot now. Whether that time we are right now. If you add 30 seconds to it, do you get? It's in the future, right? Does that mean that the date passed by the user is greater than it, or lesser than it, or too late, or too like in the past? Do you get what I'm trying to say? It's complex, having, but don't worry, Sha. But this timestamp is just based on numbers. So what we do is that you had so anytime you receive, you have to consider that there's a what 30 seconds window for it to be valid. If it is greater than that, it is no longer what valid. How do you do that? Let's say past time. You've passed this time, right? Plus 60 seconds plus this. No, it's not going to work. This is our time now. Plus, I know, am I muted? Okay. Only login controller is two. Yeah. We have one for the wallet and we have one for the email. Let's say if plus what? How many seconds? 60 seconds, have you? Maybe 60 seconds, right? So it's greater than what? The time passed by the user. This time is what? The date is not too much in the future. You get like with copy that is not too much in the future, or the date is not too far out in the past. Do you get? Hmm. Or yeah. So let's now remove 30, 60 seconds, Abby, from this timestamp, point time where we are right now. That means that thing too, that one like in the past, it must be greater than what? It must be lesser than or equal to this timestamp that you are passing. So with this, you've set a range, like a limit for how what far in the future the time can be, or how far in the past it can also be. Do you get? Is this logic correct? Okay. Date dot now plus 60 seconds is greater than the time that this thing will expire. So let's now write it down and see simple logic. Let's say our current time is what 100, right? And plus 160 plus 60 is what 160. Let's have it. Now the logic is that let's say our time is 120. What does this mean? Is this valid? Yes, it's valid because it's not too what far in the future. Let's we meant to get 170 too far in the future, right? It's going to stop working. So now if I have 160, it's not going to we need what 159 for this logic to work. That's one thing. Second complex distance is 100 minus 60, right? That's what 40. Let's say that one is the pass. And if this user now passing something like 10, do you think that it will work? No, it will not work because the time is too, too far in the past. Also, I think there should be something like the timestamp must be greater than the current time. Or instead of doing something, I can see that the timestamp that user sign must be greater than what? The timestamp. That would solve most of the problem for you. Instead of thinking about the past and all these things. So any user that is sending you a timestamp, the timestamp they are sending must always be what? Ahead of my own time. But it must not be too far in the future. That will solve almost every problem that you have with time calculation. But there are some applications that you need to like check for the past. Maybe it has been signed maybe 10 seconds ago, 10 seconds ago. At times, if your application is like time sensitive, maybe like you need less than a second, you can just put some buffer. Because by the time it's the request and everything, it's also like you can take up to 10 milliseconds, 20 milliseconds at times. You have to have some buffer. Now, but this one is too good because this is not too time sensitive, like it's still in seconds. So let's have what? Return an error. Error what? 4, is it 403 or 401? Message. Message, right? What should be message? Token, signature expired. You get me? So let's now go and try it again and see whether we send this. What do we get? What's this? Message, signature, expire. Do you get? So from there, you can like set the range for the validity of the token. Now let's go and generate a new one and see whether it will work. Let's switch our account because we need let's reject this. Let's come here. Max. Let's switch this account, right? Which account did you do the other one? This one, right? Let's try to refresh. Let's sign with this account and copy the signature and every other thing inside it. Copy the objects, paste, let's what? Remove the address. We don't need the address. Press send. Oh, we're still getting a signature expired. How are we getting signature expired? The timestamp we signed is what? It's two. It's like in the past, you get. So that's one of the things I'm saying. So we can go to our listing, our EJS, and also have some buffer. Should we have some buffer or what? Or should we change our backend code to accommodate time that are like not too far in the past? You get. So I need to like 30 seconds ahead, 30 seconds. So we can just say you get. So it's going to be like 30 seconds from the past, 30 seconds in the future. You get. So it's not going to like within that range of time. So let's now try to send this again. Still expired, right? Let's try to generate a new token. Sign. When we sign, let's copy the objects and paste it here. Let's send immediately. Oh, token still expired. Let's look at that logic very well. Okay. Timestamp. Let me check the logic here. File deleted already. Date now plus. Can anyone tell us what's wrong with this? This current date, this time that we are right now, plus 30,000 milliseconds, then milliseconds, right? Is greater than timestamp. Is greater than the timestamp that is that same. Do you get? Like that means the timestamp can be in the past, right? And now this can be in the past like this. No. I'm coming. Let's do this. Date dot now, right? Plus this 30,000 can be equal to what? Let's just say let's say 7,000 or 70,000. But the current timestamp we are right now is like 65,000. Will this logic work? It will work now. Yeah, it will work. Or okay, let's add a hand. Let's add a hand. And let's now do next thing. Let's say bits dot now is how much? 3,000, 30,000, 70,000, 40,000, yeah. Minus. Still work actually. I'm really. It's still work. I don't see why the logic is not working. But let's try to send one more. Does it take up to 30 seconds to send this? Yeah, it works now. So that's it. And I think we just wait for like 10, 15 minutes to see whether the token is still valid. Do you get? So for 30 seconds. So let's wait for 30 seconds. So if we wait for 30 seconds, I will try to send the same request again. See what it's going to return what invalid. So let's try to exit token expire. So that's it. So yeah, and we are done for today. But if you notice that within that time range, you can send like requests multiple times. The only way to cover that is by using the nonce I told you, by storing the nonce inside the tab. So there's going to be signature, timestamp, and nonce. So I'm going to combine that timestamp with the nonce, then verify the two of them using the signature. Do you get me? So once you verify and Also verify that that nonce is like the latest one that the user is meant to use. And once the user uses the nonce, log it that, okay, this nonce cannot be used again. I can increment, just keep incrementing the nonce. Like the same way we have for the Ethereum virtual machine, whereby when you send a new transaction, there's a nonce attached to it. So when you send another one, there's going to be nonce going to be 0, 1, 2, 3. Have you noticed? Yeah, so that's it. Thank you very much. And today is really, really fun, and you're able to learn a lot of new concepts. You're able to learn a lot of new concepts about how to write backend application that uses wallet authentication. Thank you very much, and hope to see you tomorrow. Bye-bye.